All right, so let's talk about these sample problems here. So the first one, when we take the fourth root of t cubed, what is that going to convert to as far as a rational power? T to the 3/4, good. And what about b? Okay, so we take x, we know our base is in the denominator, so it's a negative power, and then it's 2 over 5, good. And what about c? X to the 6 over 2, which reduces to what? X cubed. Does anybody have a different answer? Emily? Uh-oh. If you put this, you're wrong. Because what's the original index? An even number. So you know that you have to account for these never being negative values. If x was a negative and you cubed it, would that guarantee a non-negative solution? No. So what do you need around your x? Okay, so you would need the absolute value of x cubed. And then finally, what would be the rational power form for d? T to the 7 halves. Okay, so again, even though you can simplify these, right? So these ones where you have an improper fraction like this, right? You do still need to be able to recognize that how many groups of 2 can you remove from 7? 3. So really this is t cubed times t to the, and then how many would you have left after you remove 3 groups of 2 from that power? You just have the 1 left, right? So this really is t cubed times t to the 1/2, but when you combine it all into the rational power form, you can have an improper fraction. Okay, let's take a look at converting to radical form. Okay, so if we look to convert from a rational power to a radical, okay, we're going to take our radical symbol. And now, I'm still hearing when you guys ask questions or talk among yourselves, a lot of you are referring to this as a square root symbol. So a lot of you are trying to refer our base is y, the power is 1, so we don't need to write anything, and the index is 7. So a lot of you are calling this somehow something like square root of 7, y. Okay, remember this symbol, if there's an index other than the unwritten index of 2, it's called the nth root. Whatever that number is, give it the ordinal position and call it root. So this is 7th root of y. Okay, so b would be the what? Index of the denominator 2, so it's unwritten. Base of x, power of 3. So again, you don't have to simplify it or reduce it out here when you're just converting to the radical form. However, if we did in this case, how many groups of 2 can we remove from the x's? Our index is 2, our power is 3. We can remove 1 group of 2. Then how many x's would be left inside? Just the 1. Would we need absolute values around this? Yes or no? You have a 50-50 chance of being right. All right, so we have a yes and a no group. Anybody want to break the tie?
Yes. No.
Does that mean you do want to break the tie, and you'll answer how?
Yeah. I say no.
Good choice.
I say no because you already circled it.
All right. So that's my pattern is if I circle it, that's the answer. All right, so can x even be a negative number? No, because you can't take a square root of a negative, so you don't even need to worry about absolute values. X can't even be a negative, so you can leave it as it is. However you came to that conclusion. All right, in the next one, C, okay, the negative power is going to do what to our radical? Moves it to the denominator. What's our index? 2, so we leave it. It's a square root, and then it's t cubed. Again, don't worry about simplifying this because we'll go through the rules for getting radicals out of the denominator in the next section. And then finally the last one here, again we're dealing with the square root. So the negative power is going to move the whole thing to the denominator, index of 2, so I leave it unwritten. Base b, power 1, I don't need to write the 1, and so that is my simplified form. Okay, questions about either of those, converting back and forth between rational power and radical form? All right, so the last sample problem here is the one that you'll need to be able to manipulate without a calculator. Okay, and once again, what do you notice when you look at these numbers about 4 and 27? They're both what? They're perfect powers, right? They're bases that can be rewritten in exponential form. So if we look at each of those in that form, so 4 is 2 squared, all to the 5/2 power. Now we can use the properties of exponents. And when you take a power to a power, you do what with the powers? Multiply. So 2 times 5/2 is just 5. And then if you extend this out, and 2 to the 5th is one that you should be able to simplify and expand out. And if you have to, you can count it on your hands. 2 to the 1st is 2, and then you double it. You get 4, 8, 16, 32. So you get an answer of 32. Okay, and then for part B, 27 can also be rewritten as an exponential form with a smaller base, a base that's easier to work with by hand. So you get 3 cubed to the power of negative 2/3. Take a power to a power, you get 3 to the 3's cancel, minus 2, which is going to move our 3 squared into the denominator, again, which winds up simplifying into 1/9.